All right, our objective today is to graph nonlinear functions. So there's a lot of vocabulary that you're going to need to know to be able to be successful in identifying the parts of the question. So the increasing interval is the interval in which the function goes up. And we gauge this from left to right. So that's increasing. Decreasing is when the function goes, which way do you think? Down. And that is also from left to right. So that's how we read. We read things from left to right, and so that's why we focus on that for our graph. Maximum and minimum. Not all graphs have one or the other, both, but sometimes. So maximum is the highest point on the graph. It says point, that's important. That means it'll be in ordered pairs. And minimum is the lowest point. Infinity doesn't count, so it has to be an actual point that you can be able to distinguish. Even functions. Sometimes those will be called positive functions. You'll see that, I think, on your assignment today. Positive functions are symmetrical around the y-axis. That's important because odd functions, which are sometimes called negative functions, has nothing to do with anything of the numbers that are in the function. But negative functions are symmetrical around the line y equals x. And we saw that as we were graphing our inverse function, so you should be familiar with what y equals x is. A line of symmetry. We used the word symmetrical a couple times. Symmetry means a line around which a function is reflected. And we've talked about what it means to be reflected. Zeros or roots are the points. Again, we don't use words accidentally. The points where the graph crosses the x-axis. And the y-intercept, something you should be familiar with from graphing lines, is where the graph crosses the y-axis. So we're going to take this vocabulary and we're going to apply it to this graph. Just for reference, this is the function absolute value of x. So increasing. So where is our function going up? It's going up right here. That has an arrow on it. And we read from left to right. So the first place that we start at is 0 to infinity. Now we never get to infinity, but our 0 is an actual point, and so that gets a square bracket. Our decreasing, this is where we're going down. And we start at negative infinity and go to 0. Again, actually reaching that, but not reaching infinity. Now, do we have a maximum or a minimum? We have, in this case, a minimum. And that point, remember it talked about points up here, that point is 0, 0. Is it positive or negative? Remember, that's the same thing as even or odd. So is this even or odd? That has to do with where it's reflected. Is it reflected across the y-axis or the x-axis? It looks to me to be the y-axis. This is my line of symmetry. So this is an even function. Now the line of symmetry, while it is the y-axis, this line actually has a name. This is the line x equals 0. Because I don't go over in either direction. This is the point or the line y equals 0. Zeros. Zeros are the point where it crosses the x-axis. Here's my x-axis. Where do I touch? Oh, look, at 0, 0. And my y-intercept, where does it cross this axis? Same place, 0, 0. So this is just about identifying the parts of a graph and being able to read into that so that you can do further work. We're going to do more with graphing for the next week or so, and so we're going to keep revisiting these ideas. Turn your paper over. When we graph nonlinear functions, we evaluate the function for a range of x coordinates. Just like we've been doing, we choose an x and come up with a y. So here's our function, and you've been given a set of limits so that we're not picking numbers that are huge or that don't fit on our graph down here. The first thing is to create a table of values so that your work is neat and organized. And then we're going to plug these numbers into this function. That's what we do with functions, is we evaluate them at a set of given numbers. So this is 2 times negative 3 squared plus negative 3 minus 6. Calculator will give that to you to be 9. The next one is 2 times negative 2 squared plus negative 2 minus 6 comes to 0. 2 times negative 1 squared plus negative 1 minus 6 is negative 5. 2 times 0 squared plus 0 minus 6, I still put that in there even though I'm pretty sure I know what that is negative 6. Get in the habit of writing all of your work out to clean things up. 2 times 1 squared plus 1 minus 6 is negative 3. 2 times 2 squared plus 2 minus 6 is 4. And the last one, 2 times 3 squared plus 2 minus 6 is 15. That one's a little bit bigger than our graph, but we're going to make it work. So then we plot the coordinates and draw a smooth curve through them with pencil. That pencil part's important. We're going to need to be able to erase or clean things up. So we start up here with our points. We have the point negative 3, 9. 1, 2, 3 left and up 9. Negative 2, 0. Negative 1, negative 5. 1, 2, 3, 4, negative 5. 0, negative 6. 1, negative 3. 2, 4. And 3, 15 is kind of a problem. You got to kind of eyeball it. 1, 11, 12, 13, 14, 15. So that is 315 right there. So then we're going to take a pencil, and this is a curve. So that means that we're going to need to have a little bit of a U here at the bottom, and then we just kind of connect the dots. But the most important part is that U at the bottom. And then because it doesn't end, we put arrows on the end of it. The last thing is to label the curve with its equation. That's the function that we started with. So this is 2x squared plus x minus 6. And that, ladies and gentlemen, is graphing nonlinear functions.